Welcome to the podcast, the second podcast on section 1.4 called Exponential, Simplifying and Evaluating Examples. What we're going to do in this podcast is we're just going to work several problems in which we simplify exponentials, and then we're going to work a couple of problems where we evaluate exponential expressions for given values of x and y. Notice that over here on the upper right, I've written all your rules for exponents. Here's the exponent of a product, exponent of a quotient, exponent of an exponential, etc. There's 6 total rules there. I didn't number them this time. They're kind of a review from the previous podcast, but I thought we might have to refer to them, so I put them over here. Okay, let's begin. Example 1 says simplify the exponential, negative 7a to the 0 power. If you recall this rule, it says x to the 0 is 1, where x simply represents any number. Well, negative 7a is a number. Therefore, negative 7a to the 0 is simply 1, and we've completed the first problem. Let's go to the second problem. The second problem is quite a bit more complicated. This time we have a negative exponent. Remember that when we simplify, we do not want to end up with negative exponents, and to remove a negative exponent, we move the exponential to the other side of the division line. So if I take that y to the negative 4 and move it to the bottom, it will become, on the bottom, y to the positive 4. Now the y that's on the bottom has no exponent showing, so we refer to this rule, which says if there's no exponent on x, then x is to the 1 power. Well, if y is to the 1 power, that's not a negative exponent, so it doesn't move, so just leave it there. Now what about our numbers? We haven't talked about that. We have a negative 3 on the top and a 6 on the bottom, so the question is, what's negative 3 over 6? Well, the 3 on top cancels the 3 on the bottom, leaving a 2 on the bottom. So we end up on the top with the only thing there, negative 1. Everything else has gone to the bottom. Now you might say, well, where did the 1 come from? Well, everything is multiplied by 1. So there was always a times 1 on the top, and I just didn't remove it. Well, what's left on the bottom? The 2 and the y times y to the 4th. So we end up with the answer, negative 1 over 2y to the 5th. Okay, second problem done. Let's move on to the third. The third gets a lot fancier. Now we've got more variables. We've got 0 exponents, negative exponents, bunch of stuff going on. But look at the number part. 9 is not to any power, so it's just a 9. 3 is not to any power, so it's just a 3. And negative 9 divided by 3 is just negative 3. How about the z to the 0? That's kind of the next thing that catches your eye. Well, recall the rule. Any number to the 0 is just a 1. So I could just scratch that out and replace it with a 1. Well, does anything move? Yeah, we have 2 negative exponents. The y to the negative 4 will move to the top. On the top, it will become y to the positive 4. The y to the negative 2 will move to the bottom. So on the bottom it will become y to the positive 2. What about the x's? Well, think about this. X to the 4th over x to the 5th. That means x 4 times over x 5 times. And the 4 on the top cancel with 4 on the bottom, leaving 1x on the bottom. Well, how about the y to the 4 over y to the 2? That's y over y. Sounds like a rock and roll song. These y's cancel, and you end up with just 2 y's, or y squared. So our final answer is negative 3 y squared over x. A whole lot simpler than what we started with. Now let's take a look at number 4. Number 4 varies from the other ones because of this bracket. Is there an x to the negative 2 on the bottom, or is it something else? Well, it's something else because that negative 2 is being squared. So I couldn't just cancel this with a negative 2 on the top. There's more down here than just an x to the negative 2. However, the number parts are not involved with that. The number parts are standalone, just 4 over 2, and 4 over 2 is 2. So I'll just put 2 down. Now the next thing I want to do is work on that bottom, and that's exponentials raised to a power. And when you raise an exponential to a power, you multiply the power by the exponent, as in this rule. And here I've got a product of exponentials, and this rule also works for product of exponentials, but we've got a little problem that the y doesn't have an exponent. But when a number doesn't have an exponent, the exponent is 1. Now remember that this 2 is gone. We canceled the 2 into the 4 and we got a 2. So there's no 2 left on the bottom. So what is left on the bottom? We'll distribute this outer exponent 2 to your two exponents, and you get x to the negative 4, y to the positive 2, because 1 times 2 is positive 2. On the top we haven't done anything. That's still an x and that's still a y squared. But look what just happened. We have a y squared on the top and we have an identical y squared on the bottom. When you have identical factors, top and bottom, they cancel. So we get rid of the y squared. And this thing is really getting simple. Now we have an x to the negative 4 on the bottom, and its negative exponents we try to get rid of, and to do that we move them to the top. So if I start with the 2, and then I move my x to the negative 4 to the top, it becomes x to the positive 4. So that's 4 x's multiplied together. This other x is not showing an exponent, but its exponent is positive 1. And since it's positive, it doesn't move, so it stays on the top also. Well, what does that leave on the bottom? Nothing. The y squared canceled, and the x to the negative 4 went to the top. So the only thing on the bottom is just a 1, and dividing by 1 doesn't change a number. So we end up with just 2x to the 5th for our final answer. And then we go to our last example. Now things are really crazy. We got a big fraction with positive and negative numbers and positive and negative exponents on the inside, and we've got a big negative exponent on the outside. Folks, I have to tell you about these problems. These are some of the hardest problems to do because there's so many different ways to do them. There's so many different ways that it's sometimes easy to become confused. So I'm not going to show multiple ways here, even though I could show you 4 or 5 different ways to do it. You'd end up more confused, I think, than if I just show you one way. So I'm going to show one way to do this problem. If you ignore the big parentheses, don't make any changes there at all. Just leave it alone. We can work to simplify the inside, but we have to be cautious. 4 over negative 2, that's simply negative 2. Do we want to get rid of these negative exponents as part of our simplifying? Well, not really. When we distribute this negative 3, if we leave these alone, they'll become positive exponents, and positive exponents is what we want. So I'm just going to leave the x to the negative 1 and the a to the negative 2. You might say, well, what happened to the 2? Well, the 2 canceled the 2 and the 4, so it's gone. And the negative, we don't like to have negatives on the bottom, so I just moved it to the top. Now I'm ready to get rid of this negative 3 by distributing it to the exponents, and I notice x has an exponent, so I can distribute it there. A has an exponent, so I can distribute it there. But what about the negative 2? It doesn't have an exponent. And if I come in here and put a 1 on it, then the 2 has an exponent, but the negative still doesn't have an exponent, because if you remember the fundamental rule of exponential notation, this exponent only affects the first symbol to its left, which is the 2. It does not affect the negative. So if I want an exponent on everything, I have to put that in a bracket. And I can do that because negative 2 to the 1 is exactly the same as negative 2. And now I have an exponent for the negative, an exponent for the 2, an exponent for the x, an exponent for the a. And I can now distribute this to my 3 exponents. So negative 3 times 1 is negative 3. So I get negative 2 to the negative 3. And negative 3 times negative 1 is positive 3, so I get x to the positive 3. And negative 3 times negative 2 is positive 6, so I get a to the positive 6. Well, notice that both x and a have positive exponents, so they're just going to stay where they are. The only thing with a negative exponent is the negative 2, so I'll move it to the bottom. So now I'll have x to the 3 on top, and I'll have negative 2 cubed a to the 6th on the bottom, and when you cube negative 2 you get negative 8. Now I don't like to have negatives on the bottom, so I'll put it out front. I'll call this negative 3 over 8a to the 6th. And we have simplified several different types and different structures of exponentials. Now the other thing I'll be asking you to do is to evaluate for particular numbers. So I'm going to say, I have here evaluate number 4 and 5. I know that's going to take a long time. So I'm going to say evaluate number 4 and number 2 above. Use for your x's and y's, x is negative 3.6, y is 2.7, and if there's an a in one of them, and let's see, there is not in 4 and 2, we're not going to need the a, but I had a as negative 1.5. Okay, let's start off by evaluating number 2. There's a couple of ways to do it. The first way that I want to show you is called the empty hole method. We'll go back to the original problem. It was negative 3 y to the negative 4 over 6 y. Now in the empty hole method, you're simply going to rewrite the problem exactly as it is, but each time you come to a variable, in this case y, you're going to put an empty hole in its place. Before we start that though, remember, if there's more than one number in the numerator, bracket the numerator. If there's more than one number in the denominator, bracket the denominator. Always do that first. Now we begin to write negative, well, first open bracket, then negative 3, and then instead of a y, an empty hole. And that y is to the negative 4, so that empty hole is going to be to the negative 4 and then close. Then we come to our division line, so we put a slant division line because that's what's in our calculator. Then on the bottom, open bracket 6, and for a y, again put an empty hole, and then close the bracket. And then put your value for y, which is 2.7, into the empty holes. Now most of this will go into the calculator just exactly the way it looks. The only thing that won't is the 2.7 to the negative 4. So here's what you do. Recopy it, open bracket, negative 3, open bracket, 2.7, close bracket. And for 2 to the negative 4, put caret, which is kind of like an up arrow. See how it kind of points up? So it's putting the negative 4 up. Now I want to make a comment about when you're doing exponents. I think it's a wise idea. It never hurts you, and it frequently helps you to put exponents in brackets. So I'm going to put my negative 4 in a bracket, even though in this problem it wouldn't matter. And notice behind the negative 4 there's a closed bracket, so I do the closed bracket. Then I come to my division line, then an open bracket 6, open bracket 2.7, close bracket, close bracket. Now before I hit my enter button, I want to make sure my open and close brackets balance. So I start to count. I'll count up on open brackets, down on close brackets. So 1, 2, 1, 2, 1, 0. They're balanced. 1, 2, 1, 0. They're balanced on the bottom. Now you hit your enter button. When you hit your enter button, you get the number negative 0.0034846. If you're doing rounding rules and you consider the 3 and the 6 to be exact, then you would be rounding to 2 digits. If I rounded this to 2 digits, I would get negative 0.0035. Because the 8 causes the 4 to be rounded up. Now let me show you another way to do this, which is simpler. This way is called programming the home screen. I know I want y to be 2.7, so I begin by saying 2.7 store y. Now to get the 2.7, you just type the 2.7. To get your store key, look on the left side of your calculator right above the on sign. And that's the store key, and that will produce the arrow. Then to get the y, you're going to need your alpha key. On my calculator, it's alpha 1. It may be different on yours. After that, put a colon. The colon is usually second period, but you'll have to check the colon on your calculator. Now all you have to do is put in the original equation. Open, -3, y to the power, bracket the -4 because it's an exponent, close, divided by, open, 6y, close. Put a colon, hit enter, and you get that same answer. So as a general rule, doing it with empty holes is a very safe method. However, there's so much writing that there's a chance you'll miswrite something. Doing it by programming your home screen gives you the same result. You do a lot less writing, so there's a lot less chance of an error. Well, let's do one more. We'll do kind of a tough one here. I'm going to try to do number 4. That's kind of a complicated one. I put down the original problem, 4x y squared over 2 open bracket x to the -2 y close bracket squared. That's fairly pretty complicated. A lot of stuff going on there. We want to evaluate that again, just to remind you, for x equals -3.6 and y equals 2.7. And it's so complicated, I'm not even going to attempt it with empty holes. I'm just going to go straight to the program the home screen method. So I want a -3.6 in for x. So I'm going to say -3.6 store x colon. And that puts the value -3.6 into the location x. I also want 2.7 into y, so I go 2.7 store y colon. Now the x is easier to make than the y. On the second row of your calculator near the top, there's a key that says xt theta. If you just press that, you'll get your x. On the y, you still need to use the alpha key, which is the second key on the left from the top. So put that in. You've now got your values in for x and y. Since you have more than one number in the numerator, you're going to bracket the numerator. Since you have more than one number in the denominator, you're going to bracket the denominator. Since this negative exponent is followed by a multiplication, I'm also going to bracket that exponent. Maybe that's overkill on your calculator, but I'll tell you, it wasn't on mine. When I left the bracket off the -2, I ended up with the wrong answer. Okay, let's put it into our calculator. It's open, x, y. Your squared key is the key that says x squared, 5 down on the left, squared, close. Then you come to your division line, so put a division line. That's the divided by key. Then open, 2, open again. Now remember, we're programming the home screen, so we don't use empty holes. We just put an x here. X to the power, that's the caret key, x to the power, and then to play it safe, we put -2 in a bracket, and then y. Close bracket, and then squared, and then close bracket again. Something seemed fishy to me, so I stopped the program for a second. I left my 4 off the top. That was supposed to be 4xy squared, so I'm going to go back and put that 4 in there. So that's what you should have in your calculator. Now when you press enter, here's the number that you should get. If you don't get this, that means you did not put something in correctly, because your calculator cannot give you a wrong answer if you put in correct information. You should get approximately negative 1209.32. Those should be your first 6 digits. Now remember, above we had simplified number 4. And after we got it simplified, all there was to it was x to the 5th. So if I do that by programming the home screen, and here, right here, is where we simplified number 4 earlier. We got 2x to the 5th. So a good way to check this is put negative 3.6 store to x, and then just put in 2x to the power 5, colon. Hit the enter, and you should again get that number. So there are a couple of techniques for you to evaluate your exponentials, and that completes the podcast.